Welcome to a special episode of On the Line, Products Finishing's podcast for coders and finishers, brought to you in part by Gema, a leading supplier of electrostatic powder coating equipment. In this video episode of the podcast, we're taking a look at robotic process development for mechanical finishing processes. We're talking today with Mike Chappell, Senior Application Engineer with Norton Saint-Gobain Abrasives, who's giving us a video tour of the company's new Abrasive Process Solutions APS automation cell located in Northborough, Massachusetts. The facility includes a robotic-based system designed specifically to assist finishers in performing various proof of concept activities that explore what's possible through the use of abrasive products. Mike, thanks so much for taking time to talk with us today.
Yeah, thank you, Scott. We appreciate it. We always enjoy talking about the APS lab and some of the capabilities that we've been able to bring to the surface finishing industry. So again, as you said, Mike Chappell, Senior Application Engineer. We have a staff here on board here at the APS lab. We got our programmer, Nathan Jackson, also an application engineer. And then we have 16K that is part of the advanced application engineering group. So they are the in-house APS experts and the people who help to set up and run the labs on a day-to-day basis.
Awesome. Well, thanks to all of you for taking the time to show us around. Mike, to start things off, can you give us a little bit of a background idea behind the APS program and the automation cell? What is the mission of the APS team, and how does that serve finishers looking to automate some of their surface prep?
Yeah, so the idea behind the APS lab is to be able to run proof of concepts for end users as well as for automation system integrators. So the idea here is that if somebody's doing something manually, before they can take that leap into automation, many of them would go to system integrators and ask, hey, can you run our part? Can you show us that it can be done through automation? And the risk to them would be minimized. We knew that the end users as well as the system integrators a few years ago were struggling with this. So the goal of the APS team is to have that capability to be able to run nearly any part with nearly any piece of abrasive that Norton Saint-Gobain has to offer to be able to run those proof of concept labs, and that way the end user can see firsthand, speeds, pressures, these things can be shown, and you can make that leap from manual to automation, or if you're already doing automation, how to improve it. So we spent a couple of years trying to design the system to be able to all these different proof of concepts, and then the lab that we're going to show you today is kind of that final step of being able to pull all those things together.
So what are a few examples of kinds of processes that the automation cell can help finishers automate?
Okay, so we have, surface finishing. So again, when it comes to fine belting, grinding, we have the capability to be able to run buffs with compound, buffs with water, non-woven. So again, almost anything you can imagine that's in the Norton Saint-Gobain catalog, we have the ability to put that on a spindle motor or on a spindle on a head to be able to run these sorts of labs. So aluminum foundry cutoff, we can show that. Iron casting cutoff, we can show that. So it's a vast array of things that we are capable of doing. We've run several labs already this year where we've been able to show people, if you're doing it manually like this, let us show you how through automation you can go faster, less waste, improve the quality of the performance. So those are the sorts of labs that we do on a regular basis to be able to show those net results.
Awesome. Hey, can you walk us through some of the different stations and explain how each one works?
I'd love to. Appreciate it. So we're going to come into the APS lab, and we're going to do it a section at a time. And then that way we can get a real good idea of the capabilities. So we're going to start here with the stack head. So What we've done here, this head is intended mostly for grinding and heavy grinding. So we have a 15 horsepower motor on the top that can drive a 132-inch to 148-inch belt up to 3 inches wide. So again, just based on horsepower and that belt length, there aren't too many things that we can't grind on that head. You can see here we've got a setup to where we've got a bogey wheel on top, contact wheel on the bottom. That gives us the ability to be able to be directly on contact wheel or the ability to be between them onto the free belt. So that gives us some added capabilities instead of just a hard grind. The head has the capability of running dry or wet, which again, certainly in grinding gets to be a big feature where we are constantly telling customers, if we can run with a little bit of moisture, a little bit of wet, you'll get better improvement, you'll get better use of the abrasive. So we have that capability here. The bottom head here is for heavy grinding. That's a 40 horsepower motor on this head, driving an 18-inch by 2-inch steel contact wheel on this current setup using the Norton Blaze abrasive belt. So part of the issue with a 40 horsepower motor, it's obviously more than what most customers would need or would use on a regular basis. But what we discovered through working with end users is we would sometimes go in and we would see that they are grinding with our abrasives or somebody else's abrasive, and they were struggling to be able to drive the abrasive through the part. Much of that was because they might have a 20 horse motor on their head, and as soon as they made contact, they would lose the surface speed that would be best for the operation. With the 40 horse motor, we can drive through that. We can set up the speed that's necessary, and then using our DAQ system, we can come back to the customer and say, hey, out of the 40 horse motor, we use 23 horsepower. So when you work with your system integrator, let's not get a 20 horse, let's not get a 25 horse. Let's see if we can get a 30 horse motor, and then you don't have to worry about it not being able to drive through. So it's one of those kind of things. We may never use all 40 horses, but we will be able to help the end user know what horsepower they need. You can see, looking down at the floor, we've got the green grid here. The reason for that grid is, I mentioned earlier, the ability to run these labs dry or wet. So we can use coolant on it. You can see the coolant line here. It really makes a big difference in some of the heavy grind and heavy cut operations. One of the other things about this bottom setup is it is set up to be able to run 3,600 RPM using a large 18 to 20 inch wheel. Part of the reason for that is because of cutoff wheels, super abrasives, ironclad diamond wheels. Those products are designed to be able to run at high surface speed. So we wanted to be able to have the capability to run at those speeds so that we could show our end user, you can't run at 1,800, which is a standard US motor. You have to be able to run faster. Through the use of our DAQ system, we can show them that we ran the full 3,600 or 3,000, but somewhere in that range, so that they can see the capabilities of the abrasives and how it will relate to their part of their process. The next head we're looking at is the side-by-side head. This head is designed mostly for finishing. It's a 10 horsepower motor. It's driving a central shaft. You can see this setup here. We've got our Norax N889 belt, and we also have our medium vortex non-woven belt. You can see from here that we've got the capabilities of running on 4 different contact wheels. All 4 of them are different durometers. So it allows us to use a 20 durometer, a 40, 60, or an 80, which, as most finishers or grinders will know, the hardness of that contact wheel will make a big difference in how it performs. So we have the ability to use any one of the 4. This head also has a compliance device built into it, so that when we set up a program, we're able to tell the end user, this is the amount of force that we used on it. And so then we can give them that feedback of speeds, feeds, pressures, again, grits and grains of the abrasive. All that information can be gathered, given back to the end user so that they can make a good decision on their level of automation or how to improve maybe their current automation. The other thing on this head is that with this drive shaft, we have the ability to mount any sort of radial abrasives on the end of this shaft. So this particular setup shows the fixed abrasive buff, which is Norton's new buff that has the silicon carbide grain built into the cloth. Can run with about 2/3 less compound, or as we ran a lab a couple of weeks ago, the buff can actually work with just water on some of the substrates. Over here, we're showing a medium non-woven convolute wheel. Again, anything radial here, filament brushes, wire brushes, unified wheels, those are the kind of things that we can set up here and be able to run. We also have a couple of end spindles where we can run smaller products to fit in the ID of tubes or different sorts of parts. Again, the whole head is variable speed, as every piece of abrasive in this lab shows. We have variable speed capabilities, and again, it can run wet. The other thing we have with this head that has already helped us several times is the base of this head has a 7th axis. So this head can pivot left or right up to 90 degrees. Again, it allows us to be able to get into places on some complex parts where in that we don't really know what customer's going to show up next week or what his part might look like. So we added that capability so that we can program this this turning process right in harmony with the robot, and we can get our very complex part processed on this head. Okay, at this point here, we're going to move into the media to part portion of it, and Nathan's going to take over the explanation at this point.
All right, absolutely. So what we're looking at over here is the abrasive to part section of the lab. Now, the times you use this is when you got a larger part that either a robot can't pick up, or it's just easier to work in the finer areas of the part by bringing the actual abrasive product to the part. So what you're looking at here, this table actually acts as a 7th and 8th axis for the robotic cell. It can tilt and rotate, allowing us to get into those finer areas that'll be hard to reach if it was stationary. That table is sitting in, again, as you can see, these 3 coolant pans, because with this section of the lab as well, we again have the cooling capability, which will be super beneficial to integrators and end users. On top of that, what you're looking at above me and around me here is a state-of-the-art dust collection system that allows us to run just about any type of metal or composite, including aluminum and titanium. So on the end of the robot here, what you're looking at, this is a variable speed spindle, which gives us complete control over the RPM that our abrasive product is running at. That spindle is attached to this compliance device here, which gives us complete control over the force. So between these 2 tools on the end of the robot arm, we have complete control over force and speed, giving us complete customization of your process. So what you're looking at in the end of the spindle here is just a flat disc on a BT30 tool holder. And you can actually see, we'll take a look over here. The way that spindle works is any abrasive can go on these BT30 tool holders that we have in this rack over here. So these can be picked up during the process, so you can use multiple tools without any human interference. And we've got all kinds of sizes to fit just about any abrasive product you would want to take to a part. In addition to that, down here, we have the different devices. We have 3 right now. What we're looking at is a orbital sander, a Dynabelt, and Dynabrade Dynafile, and a Dynabrade Jitterbug. So these are also customizable. We can put other devices on these as well, so that we can take these over to there and do what a normal operator would be doing, but do it with a robot. So yeah, after looking at all that, that just about wraps up the capabilities and devices in the cell. And the one thing I want to finish off saying is we have yet to see a process that we couldn't tackle with this lab. We're really ready for just about anything you can do with abrasives.
So how do finishing operations take advantage of the APS Cells offerings? Can you talk a little bit about what a project collaboration with your team looks like?
Yeah, so the normal method of collaboration is through our Salesforce, Salesforce and/or Norton distribution. So what normally happens is our salespeople are out there, they're talking with the finishers, end users, about, what needs do you have? Again, oftentimes it's the same thing that's driving a lot of finishers today. It's I can't get people, I can't keep people. It's taking me a long time to train them. But that's normally how the collaboration starts. And then very quickly it goes from the salesperson introducing the end user to us to at that point there, then the emails and the phone calls start to flow between myself, Nathan Septin, Tony Landis, who is our manager of the APS team, Robin Bright, who is the manager of the advanced application engineering team. That team normally then at that point starts to ask the details, what's the part, what's the substrate, what's the goal of the operation, what's the expectation. And part of that's necessary because sometimes it's somebody saying, I just need you to show me a better way to do it manually. And so we try to help prove that, maybe not a fiber disc, maybe a flat disc or something to that effect. Sometimes we're already doing it, through automation, but we're struggling. Can you show us a better way? And then, which is most often, we're doing it manually. We can't get people. Show us how you would do it if it was, done on a robot or some form of automation. And how could I then take that information to, system integrators to get a robotic or automated cell made?
How long have you had the automation cell up and running, and what's the response been? Are there any examples of things that you've worked on thus far?
Yeah, the cell's been up and running since early this year. Like I said, we spent about a year, 2 years in design and then build. So yeah, we've pretty much had a lab, done every week since January. And some of them, I mentioned earlier, the fixed abrasive buff. We had a lab just a couple of weeks ago. End user said, "Hey, look, I'm using standard cotton buffs, struggling with life, struggling with creating fires." They already know the fixed abrasive buff. They've been using it with some small amount of compound. Their goal was, we want to see if we could use the fixed abrasive buff with just water. What would it take for us to take our buffing operation and move it from any sort of compound to just water or a coolant type setup? So we did that lab. We had another end user, 36-inch steel wheel that came to us and said, "Hey, look, we have a person who is standing there all day with a hand tool and a small grinding wheel fixing defects in the steel wheel. We can't do that anymore. We can't get people, can't keep people, don't have time to train more people." So Nathan had set up a lab here. We quartered the wheel, we put it up on the table, and the goal there was to show that using coated abrasive versus this small grinding wheel, how fast could we do it, which again was substantially faster than a small grinding wheel. And then the question of, well, how long does that belt last? Because we don't want to be in there every hour changing a belt. So they were able to run the lab, so the very fast cycle time per defect, and be able to show that that belt will not need to be changed for an entire shift. The blades are 980p, can run right through a 1-inch wide belt and get all the defects out in an acceptable manner. So those are some of just kind of high level ones that we've done where it was one of those, the end user was, we don't know if this is possible. Can you help to show us that it is?
As you're thinking on the horizon for finishers, as trends in automation continue, what role will innovations like your APS cell play? I mean, it's going to have to be, on everyone's mind more and more as the trends that you're talking about kind of evolve.
Yes, I mean, the vast majority of inquiries that we have are based on people not being able to produce the number of pieces they need to, the quality of pieces that they need to. And again, I think the entire finishing industry already knows that we can't get enough good people. We can't keep enough good people. Surface finishers, grinders, it's a tough job. I mean, we did for years. It's very tough physically. Nobody wants to do it long term. So what we believe is that the APS lab is one of those situations where, as the abrasive manufacturer, we've taken the approach that we know the abrasive side of this thing really well, And now we feel that we are now presenting this to the end users and the system integrators to say, look, if you're not comfortable, if you're worried, if you're, hey, we did robots 10 years ago and we had a tough time, try it again. I mean, 5 years in the abrasive world and 5 years in the automation world is a long time. I mean, we have a vast group of system integrators that we partner with that we have a really good relationship with. They call, they ask, we send, abrasives, we send technical help. This is our way of being able to say, look, if you are in trouble and you need some help, then get a hold of us. We can set up a lab to try to match the goals that you have for what the expectations are. If it's just, hey, look, we want to completely automate, great. If it's, hey, look, we want to automate this really nasty part of the operation, what can you do to help us? Again, our goal is that, 2 foot by 2 foot area where the abrasives is touching the media, and then that information speeds, feeds, grits, grains, backings, pressures. We can give all that information to the end user or to their integrator that they've selected, or we can help them find a quality integrator who understands the finishing and grinding field.
Well, Mike, thanks so much for taking us and showing us around your facility. Thanks to Nathan and to your entire team there. This has been really cool to see, and I think you're, right. It's just going to be the sort of thing like we'll see more and more ways that people are trying to collaborate on implementing these kind of solutions.
Yeah, and another way of being able to reach us, if again you see the podcast and you're not sure who to call, Norton APS at Saint-Gobain.com. That gets directly to us, and then from that point on there, we can start working with you right away. We can make sure that our sales group and our marketing group come in contact with you to make sure that we're offering the help that you need. But yeah, the Norton APS at Saint-Gobain.com will get us directly.
Awesome. Well, thanks so much again. And I'd like to also say thanks to our audience for taking time to view this special episode of On the Line, the official podcast of Products Finishing. We'd also like to extend our thanks to our regular podcast sponsor, GAMA. And for more episodes of On the Line, you can subscribe wherever you get your podcasts or visit pfonline.com/podcast. Thanks, and we'll catch you next time.